Good afternoon. Today I'll be sharing key steps with you about how Dow Corning has been improving the level of automation for our control system migration projects. And before we get started into that, though, I will cover just a little bit of information about Dow Corning and who we are. So Dow Corning is a specialty chemical company, about $6 billion in sales. We are we're the global leader in silicon-based technology and innovation. We have about 7,000 products and services, about 62 manufacturing offices, and we strive to be innovative leaders, unleashing the power of silicon to benefit everyone, everywhere. So that's Dow Corning. Oh, this is a slide. They were out of order. Okay. So the activities we take, the steps we take while doing control system migrations, focusing on, the first step we'll do is complete assessments. And completing health and process assessments is very key for us to identify business opportunities for automation, automation opportunities and investment strategies that allow the business to deliver value back to the business in terms of improved productivity, quality, and safety of our chemical manufacturing plants. So with that, the first step here is the systems health assessment slide. So what we do is determine when to upgrade. We do what we call a system health assessment, automation health index. So what this does is this measures the level of obsolescence in our system. So the slide that you saw before showed different categories. We too have different categories of the system. All 11 categories are evaluated. We start with the I/O to the controller, all the way up to the network infrastructure, and we evaluate each of those criteria. They all get a score. Those scores are weighted, and we end up with a composite score for a system that we can then use to determine how bad is bad. You know, we can use this to compare this score for this system versus another system in a different plant, different geography, different vendor. The tech centers and business managers really enjoy having a score because it can help them prioritize, and you can identify your biggest risk of failure based on that score. And we do have a variety, multiple platforms installed in the different locations. So this was a global evaluation that was rolled out, done the same way, consistently applied across all of our sites. So this really helps us then identify when we have capital, you're competing for capital dollars, where your business risk really is. So this was key. This was rolled out in about 2009, 2010 to do health assessments. So this was, again, system components and the health of the system itself. The next slide really gets into where, more recently, we've expanded this idea to develop a metric for value. So what value is that control system really delivering back to the business? So we identified a metric called Automation Value Index. And we all know that control systems provide a lot to our operational facilities. We can improve productivity, we can improve quality, safety. But trying to quantify that and put dollars and cents is trying to get the executives to understand that is difficult. So after a couple years, it took us to identify this value metric. And what we're trying to measure there is how effectively are we using that control system, and how is it delivering value back to manufacturing. So we identified 10 different criteria. Now it's a little harder here because you had physical components on a system that you could measure. Here we're trying to identify what function and capabilities of a control system can deliver value back to manufacturing. And then what we did is we took those criteria and we said, okay, how are they able to impact manufacturing performance? What are the key metrics manufacturing and the plants look at? And they look at pounds out the door. They look at asset utilization. Are we safe? The safety metrics, maintenance costs. So we took those criteria and said, for the weightings on their scoring, they were based on their ability to impact the productivity and the manufacturing metrics. So we basically go through all these categories, we score them, and we score them based on industry best practice. So it's pretty hard to get a really high score here. So when we look at this, we called this level of automation first, and it was a little misleading with management because, like, well, you have too much of that. So we put out a metric to say, how much are you really getting? And if you want more, your index could increase, and you'll get more value back. So again, it's scored against industry best practice. We give it a score, and this gives us the value we're delivering back to manufacturing. And it lets the business leaders understand and inform decisions about the scope. So the previous one tells us how much at risk and when would you want to migrate, but this tells us, okay, when it's time to migrate, what level of automation do you want to put in that system, and what kind of value will it deliver? So what's interesting to note on this too is It's different for every process. So this is a process-based score. You might have 5 processes on the same system. The system health is 1 score. Depending on the process and how it's configured and automated, the scores can vary significantly across that same system. So it's looking at the system score along with how effective is that automation and where do you have opportunity. If you have fully manual processes that aren't automated, you're definitely going to get more bang for your buck if you automate that process. So again, that's back to the tech centers and giving them this score to identify the value. Let me see if I hadn't missed anything. But again, it's process specific. So the value opportunity is different. If it's a batch process, you might choose 5 or 6 of these categories that are different than if it was a continuous process as far as where you're going to focus on your scope for your migration project. Okay. So what I have in here is a few examples of areas where we've actually delivered value back to manufacturing, and we've actually measured this through Six Sigma financially validated results. For example, and it's across different process types, process technologies. Specifically, we have a polymer business here where with a $15,000 capital investment, we were able to get a $1.2 million return in growth opportunity there. And that was back to a point where they wanted to create a new product recipe. We were able to put flexible batch in there, automate product turnarounds, and they saw a 20% capacity improvement on a sold-out piece of equipment. Another example here in our rubber business is we were able to, without any capital investment at all, $80,000 in energy cost savings just by putting some automated controls in there, sequence-wise. In a continuous plant with no capital, 2.2 million in growth, and that was really wrong in the site-based controller, so you could actually put coordinated control, one site rate controller that could coordinate control across a variety of process units and equipment. And then another batch example here with no capital investment with $180,000 of growth benefit. So it takes time and effort to validate these financial things, and lots of times the automation is part of other projects or it's enabling other capital investments. So it's hard to quantify this, but it can be done, and there's a lot of other, we've got tons of examples, but another one where we had a $4.6 million investment, growth return on a $300,000 capital control system upgrade. They're out there, it just takes time, and a lot of times our discipline doesn't want to take the time to document, or you have to go back to the manufacturing and the business to get these kind of numbers. But it's important, I think, that you do that, you get these numbers, because then you can really talk in the manager's talk as far as what the impact is back on the business. Okay, so this one is a similar example where this is where we were able to upgrade a control system and we gained the 10% capacity increase. Now in this case, we've got our overall equipment effectiveness score, OEE, 82%. So this process is running 82% of capacity. So we've got a gap between what its current performance is and the process nameplate. And we've got the TEEP tools, the OEE tools. We could then look at the cause codes and identify out of that 18% of opportunity, what part of that could have been improved through better automation. So by automating our startups, maybe product changeovers, we were able to identify there's a 10% opportunity on this specific process that could deliver value back to the business if we did better automation there. And we did do that. And that was just one of the 10 categories that we evaluate against. So I guess an interesting note here too is that it does take a lot of data collection and analysis to do this. We've got good tools in place to do our TEEP and OEE performance. But not all of your losses, production losses, are trivial. Automation can't fix everything, right? It can't fix the reliability of the plant equipment, physical equipment. But in this case, we identified 10% of the process could be improved through better automation. Let's see. So here's another example where we're currently partnering, developed our first integration. So not just the control system, but take it up the level into the MES and the business world. So we've developing a standard solution here that we're just starting to roll out on our Siemens PCS7 system, a batch process, where we're integrating with SAP. And here we've automated good issue and good receipts for production recording. So now our SAP inventory is real-time and updated. It's always accurate. Along with that, we have the tools in place to capture the loss events we looked at on the previous slide. So this automatically captured. There's no manual data entry. Whenever there's a outage, the control system communicates that back to this tool, and so we have good TEEP numbers. So if a batch goes to hold, one, we know it did go to hold. Two, we know how long it was in hold. And three, probably know why it went to hold. And then that identifies opportunities for us to do more analysis and identify where we have opportunities to run that process even better. So we have installed this now in 2 different sites. This new integration is the first site was a small batch mixer. I think we're doing about 1,000 transactions a month there. But we've got plans to roll this out in 3 or 4 different system upgrades already this year. And the second one we installed, it also included electronic batch records. So the second site has medical products, and the batch records were a big requirement. So rather than manual batch records, we converted over to electronic batch records. So that's rolled out. It took, I don't know, it just takes a long time on that in the IT world, but it took a long time to get that integration working, but now it's a standard solution that we can roll out, and every system we put in place, we can get integration to SAP. Future opportunities for potential is there's more opportunity there to improve that as we go forward. If we could integrate the sample results, we could actually have batch recipes, move on when sample results come in. Today, lots of times you're waiting for operators to get that result and manually acknowledge a prompt on the DCS screen to move on. Or parametric acceptance, you could automatically measure what a good process, if you know the process parameters, monitor those real time, and notify operations when you're deviating out of your acceptable limits there. We've got old slides here. So this is our life cycle. So understanding the cost when you're trying to justify cost for migration projects. Understanding the total cost of ownership, this is really important when we make this investment decision. So when the cost to implement needs to cover not just the initial upfront cost on capital projects, but it's what does it take to support and maintain that system long term. So we currently support multiple vendors. We've got a lot of different systems in our plants, and we're striving to standardize on one global platform. So in order to understand the benefits of standardization and going to fewer platforms, Siemens and Dow Corning partnered to do a study with the University of Maryland, Kelsey. Kelsey is their Center for Advanced Lifecycle Engineering. And this model was a very rigorous mathematical model that was completed that looked at various scenarios. So we looked at the different scenarios here. We have lots of platforms, different stages of life. So we looked at different scenarios, and based on that model, we were able to identify what systems go first, what makes the most sense, what platform should go first, to identify the biggest gain and value for Dow Corning. Some of the conclusions that came from the modeling is kind of similar to what we just talked about on the OEE and the capacity importance. But the biggest impact you get in the value creation of a migration is to improve that process operation and close that OEE gap and get more bang for your buck, get more production out of the same asset. We also identified with the model when you get into the cost for support, the initial cost can be impacted, it can be reduced the more you do that. If you use standard libraries and components that can be replicated over and over every project, you should be more efficient, and you should be able to reduce the cost of those migration projects over time. And similarly, if you have standard solution and a library of code as well as standard hardware components and systems, you can reduce that reoccurring annual cost over time as well. So this was a rigorous mathematical model approach that gave us insights in how to justify the cost of migrations, taking into account the full life cycle, not just how, is it cheaper to put the system A in versus B, but can I support it long term, and how much does it cost me to maintain that throughout the 20-year life cycle it's going to be there, 20, 30-year life cycle. So this slide here gets into using these metrics and how we use these. So using the Kelsey model, it helps us understand that when systems should be migrated based on system obsolescence, and then what level of automation we should deliver for the most benefit for the processes being modeled. So here we have the health index on the bottom, on the x-axis, and we have the value index on the y. And if you take a look at the number of systems that you have to support, the more systems you have limits your ability to increase the value that you're delivering back to the business. So if you can standardize and you can go from many to few to fewer, you can increase the value you're delivering back to manufacturing. So the learning and the approach that Dow Corning's been taking is that we're trying to focus our constrained resources, the few resources we do have, both money and people, and leveraging that on developing a best practice library, standard library of components on one platform allows us to give higher value back to the business. And we can do that more effectively on all migration projects globally. So every project that's done builds that library and builds that expertise within our company that makes the next project that much easier and ability to deliver more. And really this, after doing the study and reviewing this and the metrics, really it reaffirmed our standardization strategy and continued partnership with Siemens. We had done a very rigorous platform evaluation back in 2009 and had selected Siemens to partner with. And they were selected at that time based on their abilities to meet our manufacturing needs. So it really is, we've got a lot of systems, but this reaffirmed our direction to standardize on one. And I didn't hit anything. Okay. And finally, the last slide here is that the automation investment decisions, they have a 20-year business impact. And when we're making that investment, we really need to align that investment with the business strategies. And we can use this health index and the value index to prioritize investments and help the business make the best decisions and determine what level of automation they should include in their migration project. And as far as justifying projects, closing that OEE gap and taking a look at your processes and understanding where your opportunities are, that can really justify, give you solid cost numbers and justification for migration projects. And again, leveraging the standard solution across common technologies will deliver more value to our business. So Dow Corning's focus really is on taking our constrained automation resources, focusing them on delivering new capabilities on the standard platform. And really, every plant that migrates to the new standard and spends that money there makes it that much easier. We're investing in the future capability of Dow Corning globally by adopting the global standard platform. So for now, that concludes my presentation, and we can do questions later, right?
Yep, very good.
Thank you.
Thank you, Sharla. Very rigorous engineering approach, which speaks to the board level from a financial perspective to justify migration. Our last speaker before we go to a Q&A is Dave Garrett from Tryn. We'd like to invite him up to the podium here, and he has another interesting and unique scenario. For those who don't know what Tryn is actually a divestiture from the Dow Chemical Company of the polystyrene, styrenics envelope, and purchased by Bain Capital, a equity ownership partner. So it'll be interesting to see how a process automation project was executed under the auspices of a equity partner. So, Dave.
Hello, I'm also from Midland, just like the Dow Corning experience. We've had a lot of dialogue between those companies and in the community. We've also had a long history coming out of Dow with automation, with their proprietary system. Let's see how to advance this.
This one right to the right.
That one.
Yep.
So Tryn is 2,100 employees, 67 manufacturing units and 19 sites around the globe. Two major businesses, batch, continuous, mostly about half and half batch, half continuous. We're the #1 producer of styrene, butadiene, latex, and polystyrene, and also make some synthetic rubber. 5 billion, 5.3 billion, and only 2,100 employees, so we're a very lean operation. And part of that is due to the automation. So if you go in our control rooms, there's hardly any operators. It's all automated. We'll get into that a little bit more. We have a very high asset mechanical reliability. Our safety is even better than Dow's currently, and we have 5% above industry average in terms of asset mechanical reliability and productivity. So let's go through a little bit of the current situation. It's a forced march because being sold off, we have these very mature proprietary platforms that we have to replace. And we're very highly automated at the same time. So all plants must be migrated by 2020. All plants, again, are highly automated. And what we mean by highly automated for us would be a high level of state-based automation. So startup, run, shut down, abnormal situation management, degradation of the process in a safe manner, all that stuff is all automated. So the difference is it's not so much loop control where the operator gives the system permission to do something. It's the other way around. The system gives permission or notifies the operator when they need to do something. Otherwise, it takes care of business itself. So it's also leads to a lot of safe operation. A lot of process safety incidents can be avoided because you've built robustness and abnormal situation management right into your control platform. We can also take the best operating practice and build it into the code so we can run at rates all the time. So how to migrate now with minimal impact and increase our capability at the same time. So my challenge to our group and maybe to the whole group, to the industry is how to not just replace like for like, but also increase the capability of the system at the same time, get more value out of it. We have a large capital authorization that we had to go for, and again to the board, and I won't go through all the numerics, but it was a must do. At the peak, we'll have 7 plant migrations, and we can't afford schedule slippage. We want to maintain all the good stuff that we've built into the system over the years. And a little different for us than maybe some of the other folks in the room would be, we consider it valuable and justified that software is actually the larger part of this. It's not a hardware replacement project, it's a software replacement project. So we started in 2010 with an RFP and vendor evaluations, and we selected ABB as our partner. And same approach like Dow Corning, we decided to implement the platform corporate-wide to get that kind of standardization. And we have 32 plants still to go, 80,000 I/O by 2020. And we're in the middle of 4 or 5 of them right now. Just to restate, we did a lot with the legacy system. We took that embedded manufacturing operating discipline and put it right in the code. We have a lot of intelligence there. We don't want to lose it. We even had some level of templates, what I would call a kind of poor man's object-oriented programming. But you know, there was limitations. So some of the limits were it's not object-oriented. It's proprietary, so one of the big roadblocks for us is getting data in and out of the system easily. You can do it, but it takes a lot of engineering effort. And graphics and speed and capacity are all limited, so obsolescence across the entire platform. Last point, difficult to automate manual and automated procedures. So we actually tended to automate everything, which led to benefits. But on the other hand, in some cases, you need that easy interface between the two regimes. So my challenge is software is, where's the red button on here? Software is long-lived and persistent. That, to me, is a really key thing. It's not just about hardware. It really is, to me, about software. So software has a huge impact on productivity, quality, safety, EH&S, and costs. In our batch plants over the years with that mod platform, we doubled productivity. And I was part of it, so I don't even have to give you the numbers. I know, I did it. So we don't want to lose that. How do we get more bang for the buck? So we need an overarching vision that takes architectural principles that are generic, right, and addresses every area, methods, tools, quality software, and work process, because these control systems, we underestimate the impact on manufacturing and the entire organization that they have. They're really part of the culture and the environment of manufacturing. So we want that work process to be capable of how we deliver software, how accurate it is, how fast and how cost effectively we can make change, because we don't want to just put these systems in and forget them. We want them to live over time. So we want quality software, we want the tools to do this cost effectively, and we need some standard methods and standard models. So in terms of method, I'm going to try to go through these as fast as I can, and I don't expect everyone to understand every nuance of what I'm saying, but I want some buzzwords to get into your consciousness. Physical model. So the physical model in the old platform was very flat. It was at a unit level. We challenged ourselves to go with the industry standards of S88 and S106, and we're taking that physical model and we're reevaluating it, okay? So it's not like for like anymore. Even more important for us is the procedural model, because that's where we get the big bang for the buck, automating what you can automate. So S88 and S106 are very, very valuable models in our mind. And we already were doing an S106 kind of model. Because we have batch plants, we want to also now move into the S88 world, but we want that reliable state-based automation also in the DCS. So how to balance all that. So on the end there, I have a column plus. Now that we've done it, we've migrated some plants, I can say that if you do this the right way with your physical model and your procedural model, you really get some value out of reuse, and we've already heard that today a little bit. In terms of automation code in the legacy platform, it was spaghetti code. Very difficult to tease out what the code is actually doing in the process. Now that we've gone to an object-based way of coding libraries, there's a lot of reuse you can get out of that, and it's also more understandable for operators, more predictable. This object does that. This object does that. They don't have to go hunting and pecking, or the engineer to troubleshoot the code as much. In terms of batch automation, the legacy system was very limited. Now we have full batch integration, and we've already programmed and will deliver to the plants more procedures than they had before, with the promise that as new products and recipes come down the line, we can scale those up faster and reliably. In terms of alarming, we already had state-based alarms. We still have state-based alarms. And in terms of plus, with all the reuse and libraries, we now get, in my mind, an increased level of validation. In terms of abnormal situation management, again, we get validation. And I'll talk a little bit more about that in a minute. In terms of tools, how do we migrate all the software that we've built up over time? It's buried in the code, spaghetti code in many cases. How do we get that out? So we have a tool that we worked with ABB on to get the code into a functional spec. And as we have that functional spec, we then re-engineer it through forward engineering tools into the new code for the new platform. So I highlight in red there, functional spec to code. I would say for the first time in my 35-year career, we now have functional specs. We write the functional spec and generate code from it. The two are linked. There's, in some cases, some manual work you have to do in between, but only a very little bit. So for the first time, I can print out a report and show you how this plant will run. And it can be reviewed by a HAZOP guy or management or a new run plan engineer. In terms of tools for central development, we wanted to use the cloud. We are now doing all of our development, all of our re-engineering, all of our validation, simulation and testing, graphics development is all done in the cloud. And I would say that's really cool. In terms of batch recipe and PLM, We've now linked up all the way from our global recipe system all the way through into the batch plant. So we have truly, also for the first time in our corporation, recipe transformation, I would call it. Okay, quality software. So you work on your methods, you work on your tools. What about the software itself? A key thing for us was reusable libraries, so use the off-the-shelf libraries, and develop new libraries only where they're needed. So we developed basically 2 libraries that weren't available from ABB in the way that we wanted. One was material transfer library, and one was simulation library. So with our material transfer library, we can now set up all these batch transfers in a plant very easily and quickly. And with simulation, also in a batch plant, it's very important to us to be able to simulate the entire batch plant in a medium fidelity level so that we can do startup, run, shut down, and let the plant run or let the batches run through the process without any manual interventions, and then insult test it all in a simulation environment. So we can do that now. In terms of operator interface, the new operator interfaces, we've all seen the new operator interfaces, Windows-based and so on, are very powerful, very fancy, and you can do an awful lot with them. And what's really neat is if you use, situational awareness management type principles in these graphics, the way the operator interfaces with them is much better than the old platform. So I call it process awareness. In terms of links to enterprise, SAP, and so on, we're linking these up now. All the plants will be linked up to SAP for production order management. And we are also looking at maintenance type work process to link that into the system. In terms of asset management, let's call it plant data, we have lots of plans. What we've demonstrated so far is what I would call embedded documentation or single source data. So from our P&IDs, process engineering data, we put that in a database, and it's single source within the control system. Our simulation uses it, the plant uses it, and it's also at the operator fingertips. In terms of safety systems, it's pretty much status quo. The loops we had on the old system, we're putting on the new system. And the old system was capable in terms of sys based in the same platform, and same thing with ABB. All right, work process. Work process is an often forgotten box from the front slide that I haven't heard people talk about. And for us, this is critical because we want a very, very high level of performance in our software. We want a very high level of validation. And the days of cowboy engineering are over. So you can't just go in a control room, hack some code, and walk away, and then you get a call from the operator at midnight, my loop's not working. That still happens, rarely, if it should never happen. But we want to embed work processes into the culture and the tools so that every change is simulated and documented and goes through updating the functional specs and so on. So we put a lot of effort into work process. We still have some ways to go. We still need some tools and a few better ways of doing things, but it should be easy to make a change, but also robust. So I call that application generation and maintenance. We need some tools. We have now put them across the enterprise. Everything's in a database. We want to validate and test it. So we want these simulations to work. They need to be kept living. They're linked right to the P&IDs. In terms of management of change, that's a requirement. We got to test against simulation. If we have an RCI, we can bring that back against the simulation. In terms of training for operators, before it was paper-based. Now we've got a medium fidelity simulation. They can train as if it's a real plant. So the things in red are the ones that I felt like were even bigger pluses than normal that we've been able to extract out of the system and our new work processes. So how to put all this in one picture? I presented 2 years ago. It's basically the same picture, but now we've actually done it. Back then it was a little bit of theory. So if this red light will work, voila, automation engineer. He has all the legacy code at his fingertips. We take this legacy code, we stick it into a database. He can then re-engineer that functional spec, print it out in a report, we re-engineer it, bring it back into the tool, then pump it into the application code. At the same time, we've got our P&IDs. We take the plant data right off the P&IDs. Every tag device data gets merged into the application code. We also take the P&IDs and create what we call a simulation application, and in a totally separate tool, create simulation codes. So the simulation code is derived directly from the P&IDs. So we've had a guy that knows nothing about our process sit down with the P&IDs and draw out the M&EB simulation. And then we have process technology experts that make sure this plant is running the way he thinks it should run. We also get the plant guys involved to approve unit by unit and the system as a whole before we take it to startup. So we need methods, we need tools, we need work process, and quality software should be the result. In terms of now money, what kind of money are we talking about? Whereas before, to generate functional requirements, functional specs, detail specs, code, test, simulate, validate, train, and commission, add that up to 100%, we're driving towards 1/3 of that by the time we get to those last few plants in 2020. Our very second plant, we're planning right now to reduce that even more than 65% of the original. In terms of application, I don't want to go into all the license fees and then maintaining all this stuff and Windows licenses and replacing Windows, but just take one slice and say, all right, if you're going to have so much software in your system and a lot of technology and intelligence in your system, what does it take to maintain that? So if you address work process and you had a good architecture to begin with and you addressed some of those other areas, I already see, and I've managed an application group for many years, that we will easily hit half of what we do today on the legacy system. So that's some of the value you get there. So in summary, we've seen a significant improvement in process flexibility with batch. We've seen improvement in reuse and cost advantage for generating these applications, but also maintaining them over long term. I believe the way that we remodeled our procedural model, we're able now to have the operators actually understand the process better than they did before, or new engineers coming in. The process technology is now front and center instead of buried in the code. The last bullet point, I'll just skip to that, is enablement of data share and link across the enterprise. That is really important to be able to get all the data out of the system now. So that summarizes it for me.